setup of a symmetric key. Second tunnel is symmetric and exchanges identity between the devices. Third tunnel is asymmetric and exchanges a symmetric key. And fourth tunnel is symmetric and exchanges data, or encrypts data. So that's it. That's what I want. That's the first question. Second question. Alice wants to send to Bob the encrypted message. Which key? She has to use the public key of Bob, which will encrypt the message. And she has to use her own secret key, which will encrypt the hash of the message, which is the signature. Question number 3. It's a long text, and which makes me the king of all bullshit texts. The answer is ping is impossible due to the fact that there is no circuit. Now, if you looked at EIGRP and started computing which is the best path and which is so on and so forth, you were wrong. You were just mangled, in the text. EIGRP is a routing protocol, so it exchanges data between networks. How many networks are there in the ping? Only one. 1000. So it can't be EIGRP. It cannot play any kind of role because it's just one single network. So no circuit, it means no ping. Question number 4 has the answer. Yes, of course it will work. The only problem is that the ping will go from router 3 to router 4 and then to router 2, on top of that. And the reply goes directly from router 2 to router 3. Explanation, why? Because frame relay automatically uses reverse arc to map an IP address to a Delsi number. And it does it automatically. However, if we do it manually, no problem whatsoever as long as I still have a circuit. So, circuit, it means ping is okay. Question number 5. We first need to set up routing between routers, so that's the VPN, IPsec. We need to set up routing between routers R1 and R4. I don't know how, and I don't care. Second thing, we need to set up IKE phase 1. If you wrote IKE phase 1, then it's perfect. If you wrote, we need to establish a partnership between routers R and 4, giving identities based on a shared secret password or a certificate. Then you said we establish IKE phase 2, which means if the authentication in the first step was okay, then we need to exchange a shared secret key. I take it correct in both cases. If you say we need to set up routing, we need to set up IKE phase 1, we need to set up IKE phase 2, and we need to set up an access list or any kind of trigger which will match the traffic from network 1 to network 4 and actually apply encryption, it's fine. If you said we need to set up IKE phase 1, IKE phase 2, an access list and the crypto map to actually bind everything together, it's also correct. So I think the reply is correct as long as you cover all these 4 steps. Yeah. So it doesn't matter how you actually explain them. If you explain them properly or logically, I shall take it as correct. Question number 6. Of course, the technology must be MPLS because any other technology will not be independent from the providers. The only thing that the network administrator must take care of is broadcast or multicast. Because in MPLS, it is a non-broadcast system. So how will you solve multicast? Well, in networks 1, 2, and 5, there must be a server which intercepts the multicast and actually pushes it to the other networks. They are the same or different labels. But MPLS is the technology. Yep.
Application
So if you wrote another kind of solution, but it solves multicast and it's done at application level, it's okay. Still, it's correct because applications are independent from the layers below. Yeah, so you'll get full points. Okay. Question number 7. This is the first question where I have to actually write something. I think it's the only one on which I have to write something. On question number 7, 96 without 16 plus nothing. And 98, it is 110010. This is priority. This is drop probability. Higher drop probability means it will be dropped. So 96 will pass through, 98 will be dropped. Question number 8. How many partnerships you need to write? In total must be 8, because you have to introduce the loopback interfaces and actually create a partnership between the loopback interfaces. Question number 9. What routes we are going to see on router 1? So on router 1 we are going to see the following. Directly